Hello friends, welcome to my channel Dey Sir's Chemistry Coaching. From now you will see most expected questions with explanation for NEETs and JEEMAINS exams. Please follow all my classes and please subscribe my channel. Okay, so let's start. GOC, this is General Organic Chemistry. In NEET you will get 5 questions from GOC. GOC are the chapters of class 11, that is the basic concepts of organic chemistry and hydrocarbons. And in JEEMAINS you will get 3 questions from GOC. Okay, so this is a vital chapter, and also this chapter is the foundation of organic chemistry of class 12. So let's see. So the first question is, which carbocation is the most stable? Trimethyl, triphenyl, neopentyl and tropolium ion. Sometimes they used to give in structure, but most of the cases they used to give the compound. So listen, so the answer is direct, right? The answer, it is tropolium ion. Okay, tropolium ion contains 7 bond, that is heptagonal structure. Heptagonal or septagonal structure, 1 2 3 4 5 6 7. Alternatively there are double bonds and here positive charge. This is tropolium ion, and this is the most stable carbocation. This is the most stable carbocation, is the most stable carbocation. So now next question. Which carbocation is the least stable? So methyl, phenyl, trimethyl and triphenyl. First see the question, which is the least stable. Okay, answer is phenyl. It is the least stable. So remember it, if any carbon carries multiple bonds, double or triple bond, that carbon becomes very high electronegative in nature, and due to very high electronegativity, that type of carbocation are the least stable. So due to sp2 hybridization, you know that if any carbon possesses double bond, it carries sp2 hybridization. So due to sp2 hybridization, the carbon is highly electronegative, hence it is unstable So remember it, if any carbon carries double bond or triple bond, actually they have very little existence or life. Similar examples: CH double bond C positive, carbocation. This is also least stable. C triple bond C positive, least stable. This is acetylene carbocation, least stable. So remember it, if any carbon carries multiple bonds, double or triple bond, they are least stable, short-lived, because the carbon has highly electronegative in nature. So the next question: see the notes, okay? Now see the notes, then I will give another question. Remember it, the decreasing order of carbocation, carbanion and free radical. This is a very important point. The decreasing orders of carbocation, carbanion and free radicals. Carbocation and carbanions are charged species, while free radical is a neutral species. So if you consider only the alkyl group, considering the alkyl groups, if you consider only the alkyl groups, then remember it, trimethyl carbocation is more stable than dimethyl carbocation, more stable than ethyl carbocation, and which is more stable than methyl carbocation. So remember it, trimethyl carbocation is more stable than dimethyl carbocation, is more stable than ethyl and more stable than methyl. If you consider the free radicals, same order is followed. The stability order of free radical and carbocation are same. The stability order of free radical and carbocation are same, provided that there must be alkyl groups. If you consider only the alkyl group, the stability order of carbocation and free radicals are same. You can say it, 3 degree carbocation is more stable than 2 degree, 2 degree carbocation more stable than 1 degree, and it is methyl carbocation. Similarly, 3 degree free radical is more stable than 2 degree free radical, more stable than 1 degree. This is 3 degree free radicals, 2 degree free radicals, 1 degree free radicals and methyl free radicals. If you consider carbanion, in case of carbanion the reverse. In case of carbanion, reverse occurs. That is, methyl carbanion is more stable than ethyl carbanion, which is more stable than dimethyl carbanion, which is more stable than trimethyl carbanion. So remember it, the stability order of carb cation and periodical are same. Tertiary carb cation or periodical is more stable than secondary, secondary more stable than primary, more stable than methyl. But whenever you consider the alkyl group, then the reverse occurs. That is, methyl is more stable than 1 degree, more stable than 2 degree, more stable than 3 degree carbocation. Okay, and the stability order of these carbocations are on the basis of hyperconjugation. The stability orders are these stability orders are these stability order is as hydrocarbon hyperconjugation. Okay, hyperconjugation. If any carbocation or periodical or carbanion is attached to sigma bond, that is the adjacent carbon, if contains only the sigma bond including hydrogen atoms, then it is stabilized by hyperconjugation. Once again, remember it, if any carbocation carbon or periodical carbon or carbanion carbon is attached to that carbon atom which again attached to only sigma bonded hydrogen, then it undergoes hyperconjugation, that is shifting of hydrogen takes place. And the stability order of these intermediates are on the basis of hyperconjugation. But remember it, when phenyl group is present, then once again, when phenyl group is present, then the stability order of carbocation, carbanion and periodical are same. See the note, in case of phenyl group, okay, if you consider the phenyl group, the stability order of carb cation, carb anion and periodical are same. Considering the phenyl group, the stability order, the decreasing order of stability in all the cases triphenyl greater than diphenyl greater than benzyl greater than allyl greater than trimethyl greater than dimethyl greater than ethyl greater than methyl. So remember it, this is the stability order of carb cation and periodicals as well as carbanion. Triphenyl, diphenyl, benzyl, allyl. Okay, and you know the last one I have already discussed earlier. So this stability order follows in case of all. The decreasing order of stability order follows by all carb cation or carb anion or periodicals. Everywhere the stability order is followed. This is triphenyl if the carbon which carries positive charge or negative charge or free radical contains 3 benzene ring, that's called triphenyl. So triphenyl carbocation is more stable. It may be carbocation, it may be free radical, it may be carbon ion. Everywhere the same rule is followed. Then diphenyl then benzyl. If benzene contains CH2, on the head benzyl and then allyl. So remember it, whether it is carbocation or carbon ion or free radical, this is the stability order. And if you consider the alkyl group, I have already mentioned the stability order earlier. I have seen entrance question to mention the decreasing order or increasing order of stability. So let's check the next question. Once again, remember it, you will get 5 questions in NEET from GOC chapter. GOC includes basic concepts in organic chemistry as well as hydrocarbon. Okay. Now, in the following question, in the following reactions which intermediate formed. Once again, in most of the organic reactions, there are mainly 3 intermediate. Reactant changes to intermediate, intermediate then change into product. Intermediate has very short life period. Carbocation, carbon ion and free radical are main intermediates. There are some reactions where I have seen carbenes, nitrines and benzynes intermediates are formed. I will discuss it. Okay. Now, the first reaction and the second reaction so these are the 2 reactions. Okay, these are the 2 reactions and the 2 reactions follow some intermediates. You have to mention which intermediates are formed here. Okay, carbon ions and carb cation. Number B, carb cation carb anion. Number C option, carb cation free radical, and number D option, free radical and carbocation. Can you tell me the question answer? This is the first reaction. It follows some intermediate. This is the second reaction. It goes with some intermediate. These are the options of intermediate in the first reaction. These are the intermediate in the second reaction. These are the intermediates. Which is the correct option? See the answer. Whenever you do the answer, the main thing is explanation. Don't go through the quantity of the question. Go by quality of the question, which has some depth or conception. So this is addition reaction. This is also addition reaction. It follows Markovnikov's rule. In case of addition reaction of unsymmetrical alkene, these are the unsymmetrical alkene because the double bonded carbon contains different number of hydrogen atoms. In case of addition reactions of unsymmetrical alkene, if peroxide is given, then anti-Mark rule is followed. Addition reaction which follows Markovnikov rule goes through carbocation intermediate, and if any reaction takes place in presence of peroxide, remember it that always follows free radical mechanism. Not only in this, you know that any reaction if occurs in presence of sunlight, or any reaction if occurs in presence of peroxide, remember it, the reaction goes via free radical intermediate. So remember it. Now the next, okay, I think you understand it. This is my direct classroom coaching format, so please cooperate with me, okay. Now next question. A reaction is given, okay. A reaction is given product. They will give the option which of the product is formed, okay. They will give the option which of the product is formed. Now without writing any option, can you do the reaction? At first tell me what is the name of the reaction. This is an example of pinnacle pinnacolone rearrangement. This rearrangement follows. These are not options, okay. These are not options. Directly without writing the option, understand it, because this is direct classroom format coaching without any rest. So pinnacolone rearrangement, and remember it, During pinnacle-pinnacolone rearrangement, carb-cation or carbonium ion, carb-cation is intermediate. And remember it, if any reaction proceeds via carb-cation intermediate, always consider the most stable carbocation should form. And the stability order of carbocation is, the stability order of carbocation is, you know that tertiary greater than secondary greater than primary and greater than methyl carbocation. So in any addition reaction, if in any addition reaction or elimination reaction, if carbocation intermediate is formed, remember it, most stable carbocation should form. If primary carbocation is formed in the first step, it has a tendency to undergo rearrangement to form secondary carbocation that is more stable than primary. If secondary carbocation is formed, then it has also a tendency to rearrange into more stable carbocation, that is 3 degrees. So remember it, this point, okay. Now see the mechanism. So remember it, mechanism follows very important role in organic chemistry. At least 3 to 4 questions you will get from the mechanism, okay. Now see the mechanism of the question, everything understand. So remember it, pinnacle-pinnacolone rearrangement follows carbocation intermediate, and we know that carbocation intermediate is formed which is more stable. The reaction takes place in acidic medium, that is concentrated sulfuric acid. As oxygen has lone pair of electrons, so oxygen attracts, the lone pair attracts the proton. Now question is that if the proton gets attached here, it will becomes OH2 positive, and whenever you remove OH2 positive, this carbocation is formed. This carbocation contains benzene ring which has conjugated system. Alternate double and single bonds are called conjugation. So another way, if you consider this hydrogen positive ion gets attached with this oxygen atom, so this oxygen becomes positive charge, and so by removal of water you get positive here. So the probability is that either this carbocation is formed or this carbocation, which is more stable. This carbocation contains only 2 methyl groups which are again connected through hydrogen by sigma bonds. So this carbocation is stabilized by hyperconjugation, while if this carbocation is formed as reaction intermediate, this carbocation is stabilized by hyperconjugation as well as resonance. That's why this carbocation is more stable than this. So remember it, the carbocation which is stabilized by resonance is more stable than the carbocation which is stabilized by hyperconjugation. How do you know which carbocation is stabilized by resonance or hyperconjugation? Once again remember it, okay. If the carbon which carries positive charge, same thing happened in case of free radicals, same thing, okay. If a carbon which carries positive charge is attached to carbon atom which are further attached to only sigma bonded hydrogen, that is stabilized by hyperconjugation. If a carbon which carries positive charge, which is again attached to carbon atom which has multiple bonds, conjugated system means alternate double and triple, benzene has conjugated system, they are stabilized by resonance, and resonance stabilized carbocation is more stable than hyperconjugation. So it attached here, because just now I have discussed that this carbocation is more stable. So you get the intermediate listen, in this very short time I have little bit time to explain, but I will try to explain all. Okay, actually my target is to hit the topics from where most of the questions in mains and NEET are coming. So any positive, as oxygen donates electron to the positively charged proton, this is proton actually, any hydrogen positive ion is called proton. So the oxygen becomes positive charge. As oxygen is very high electronegative than carbon, so oxygen cannot have positive charge. That's why oxygen attracts the bonding electron from carbon, and elimination of water takes place, and you get the intermediate like this. Losing of electron makes this carbon positive charge, so you get carbocation as intermediate. You get carbocation as intermediate. Sometimes you can say carbocation, sometimes carbocation, both are correct. It is also called carbonium ion. Okay. Now, carbocation has a future to undergo rearrangement to form more stable carbocation. That's why this carbon methyl group shift here. So it is called 1,2 methyl shift. It is called 1,2 methyl shift. So you get the product COH positive, CH3 benzene ring, and here CH3 comes. You know that carbocation is intermediate, carbocation is not the product. That's why here this bond shifts here, and there is elimination of H positive ion. This part is called loss of proton, that is deprotonation. This part is called deprotonation, loss of proton. So you get the product CH3C double bond O C CH3 benzene ring and CH3. So this is called pinnacle, and this is called pinacolone. This is called pinacolone, and that's why this type of rearrangement is called pinacolone rearrangement. This is a very important for your time. Okay.